we are calculating electric field. The electric field at axial point P, that is the point lies on x-axis. On x-axis at a distance plus x from the center of the disk. Okay, what do we do? We already have studied E is equal to minus del V, or E is equal to minus dV by dx. This is what we are going to use because we want to find out along the x-axis. Therefore, E plus x is equal to minus dV by dx. This is equal to minus d by dx of the entire formula for potential. This is what I am going to use. Sigma by 2 epsilon naught into a squared plus x squared whole power half minus x. Is that okay to you, sir? Is that okay to you? Now we have understood why I have written this expression for potential. The idea of writing the expression for potential is to tell you how we arrive at potential at the center of the disk by substituting x is equal to 0. The next point is to derive expression for electric field using this expression, this relation. Okay? Now, let us try to solve this. This minus sign, let me take it inside. Therefore, I will get this like this. Okay? This will be, if I differentiate this, sigma by 2 epsilon naught constant minus of minus plus x. If I differentiate dx by dx, 1 minus, this is, if you differentiate this, x by a squared plus x squared whole power half. Okay? Is that okay to you? Is that okay to you? Now, this is for x greater than 0. In a similar way, similarly, for point on the negative x direction, E of minus x will be sigma by 2 epsilon naught 1 plus x by a squared plus x squared whole power half. This is for x less than 0. Is that okay to you, sir? Now, if you ask me what is the electric field at the center, all that you need to do is substitute x is equal to 0. I will write that here. Okay. center. X is equal to 0. Therefore, E naught will be sigma upon 2 epsilon naught. No harm in this. Now, if you assume that electric field at a point lying at a large distance from X, for a large distance from the center on the x-axis, okay, on the x-axis, that is x very much greater than, we need to modify. How do we do that? E is equal to sigma by 2 epsilon naught. Please listen what I am doing here. You need to carefully understand. 1 minus the x is here. In the denominator, I am going to take x squared outside because it is root. If it comes out, it will be x. Therefore, x 1 plus a squared by x squared whole raised to the power of. I suppose you are able to follow this. Fine. X can be struck off to get sigma by 2 epsilon naught 1 minus 1 upon 1 plus a squared plus x squared whole power half. Here I am going to use binomial theorem and neglect higher powers of x. Therefore, using binomial theorem, okay, neglecting higher powers, of course, sigma by 2 epsilon naught into 1 minus, if I take this up, it will be minus half. Therefore, 1 minus a squared by 2x squared, neglecting other powers. Therefore, this becomes equal to sigma by 2 epsilon naught 1 minus 1 minus of minus plus a squared upon 2x squared. Okay? 1 minus 1 will go off to give me an expression as E is equal to sigma a squared upon 2 into 2, 4 epsilon naught x squared. This is what I get. Am I right, sir? Am I right? No. In that expression, I am going to multiply and divide by pi, value will not change. If I multiply and divide by pi, what happens? Sigma pi a squared divided by 4 pi x squared epsilon naught. Is that okay to you? Or I will put it this way: 4 pi epsilon naught x squared. Now pi a squared is the area. Sigma is the surface charge density. Therefore, surface charge density into area will give me charge. Therefore, this expression can now be written as q by 4 pi epsilon naught x squared. That is the expression for electric field due to a charged disk. We have taken the entire charge disk. For this entire charge disk, what is the electric field at some point along the axis of the disk? at a distance x from the center, it is E is equal to Q upon 4 pi epsilon naught x squared. Is that okay to you? If that is okay to you, we move on to the next topic for discussion in our syllabus. Please take this down. I will rub and go into the next topic for discussion. Okay? Let me rub this off. Our next topic for discussion is potential energy due to a charge distribution. Due to a charge distribution. This is our next topic for discussion. Potential energy due to a charge distribution. Okay, we proceed this way. Let us assume we have a continuous charge distribution. We have a continuous charge distribution. And let us say rho to be the volume charge density. When I say volume charge density, I mean charge per unit volume. Still, if it is not clear to you, rho is equal to charge upon volume. That is what I say, charge per unit volume. It is simply called volume charge density. So, we are considering a continuous charge distribution and we assume rho to be its volume charge density. In the continuous charge distribution, let us consider a small volume. The small volume we are considering is dV. We want to know what is the charge contained in the small volume. Therefore, we write charge contained in the small volume dV. As I said, rho is charge by volume. Therefore, charge is rho into volume. Therefore, this will give me rho into small dV. Is that clear to you? Is that clear to you? If this is the charge contained in small volume, what is the total charge contained in the volume V? Total charge contained in volume V. This I will write as Q is equal to integral of the volume to V. Step by step by moving, I suppose if you have been listening, definitely you will follow what I am saying. Now, I want to calculate potential energy. To calculate potential energy, I need an expression for potential. If V is the potential at a point, if capital V is the potential at the point occupied by the charge, rho dV, then electric potential energy of execution of such distribution. What is that? Potential energy is denoted by letter U, is equal to half integral over the volume V, rho, capital V for potential, into dV for volume. You may now ask me, how are you writing this? How do you write this? For those people, I am writing here potential energy, P for potential energy of a system of charges, of a system of n charges. Let me put it that way. System of n charges.